Hello everyone, this is Pravalika. Today we are making demo video of Introduction to Artificial Intelligence and our teammates are Raju Jakkireddy and Arvind. Today our project is about Intelligent Pathway Navigator. And now let's talk about the problem statement. The main objective of the project is to train the agent the best transition from any grid point to the target state. The system should incorporate machine learning algorithms to predict traffic conditions and recommend alternate routes. The main goal of this project is to reduce the traffic congestion, travel time, and improve overall traffic efficiency in the city. The system should also be user-friendly, accessible to all drivers, including those with limited technology experience. Now let's talk about the problem approach. The primary objective of this project is to teach an agent how to navigate through a grid environment and find the optimal path to reach a goal state using Q-learning method. The project can be extended to find the fastest route between any 2 points in the real world. To achieve this goal, the project will involve designing a grid environment for the agent, defining the agent actions on reworks, implementing the Q-learning algorithm, and the testing the agent learning using various scenarios. Let us talk about deliverables. The project deliverables include designing a grid environment for the agent, training the agent to find the optimal path, at least to reach the goal state using Q-learning model, and testing the agent learning using various scenarios to evaluate this performance is much more important. Especially, the project will involve creating a grid environment with clear markings for the goal state and the obstacles, training the agent to learn the best way to navigate through the grid to reach the goal state, and testing the agent ability to find optimal paths under different conditions. And the evaluation methodology is the Q table records the rewards for each state in the grid. The graph depicts the agent learning tragedy from the first episode to the end of the training course. We'll use the Q learning algorithm, which takes into account sample complexity, regret, and the average total rewards per episode. We will also compare policy optimization algorithms, policy gradient algorithms, and A3C.
Hello all. So here let us look into the project code. So our project is on like Intelligent Path Navigator. So coming to the libraries, the important libraries we are importing is like Pandas and NumPy, and then we are creating a grid environment where the agent is to be trained. So totally there is like 10 states, and among the one is a goal state in the grid that agent to learn. So by creating the reward matrix for each state and action in the grid as follows. So the grid will appears to have a 11 by 11 rows and 11 columns for a total 121 states. So each state is associated with a reward value, and which is given by the corresponding value in the rewards array. The reward values are negative for the most states. The only exceptions are like the states in the fourth and ninth rows of the fifth column, and which have the reward value of 0, and the state in the second row in the sixth column, which has reward value of 100. Then coming into the next function to initializing the Q matrix with zeros. So here we this code defines a function called initQ matrix that takes two arguments, which is m and n, which represents the number of rows and columns in a grid, respectively. Then the function returns a NumPy array shape in m and n, m comma n, that contains zeros. Then the code calls the initQ matrix function with arguments of 11 comma 11 to create the Q matrix called Q matrix. The Q matrix is used to store the expected rewards associates with taking an action in a particular state in the grid of the environment. Then coming to the next different function, This code defines a function called init set init state that takes an optional argument of rooms, which defaults to 11. The purpose of this function is to randomly select an initial state for an agent in the problem. Uh, Going forward, and this function defines normalizing Q matrix that takes a NumPy array, uh, which is like an Q matrix as an argument. The purpose of this function is to normalize the values in the Q matrix to range of 0 to 100. And in order to make it easier to visualize, interpret the Q matrix. Then going forward, uh, the simple Q-learning model building reach the goal state. This function called train agent takes an integer argument of episode. So the purpose of this function is to train the agent using the Q-learning algorithm. The function first initializes some variables, including the discount factor gamma and the initial state for the agent, which is selected using the setInit function. So the function then enters a loop that continues until the agent reaches in the goal state. In each iteration of the loop, the functions select the random valid action for the current state of the agent. Then, based on the rewards associated with the agent, each action in the rewards array, the function then calculate the expected reward for the current state and action using the Q-learning formula. So, which expected rewards for the next state. The Q value for the current state and action then updated in the Q matrix using the Q-learning update rule. So this function also prints the updated Q matrix and old and new states of the agent in each iteration for debugging and the visualization process. So finally, the function returns the total number of time steps taken by the agent during the episode, as well as the updated Q matrix. So this Q matrix can be used in a future episodes to guide the agent behavior and its performance. Then coming to the fully training for the agent. So this code defines the loop that runs iterations of the total step 0 and the iterations 500. So of a training an agent. Then each episode of the function returns a total number of time steps taken by the agent as well as the updated Q matrix. So the total number of time steps taken in each episode is added to a list called learningstep.bi. Additionally, the sum of all the values submitted in the Q matrix is added to a list called rewards.curve. Once all the episodes have been updated, the code prints the total number of time steps taken by the agent over the entire learning process, which is the sum of the time steps which is taken in each individual episode. So overall, this code running the multiple episodes of the Q learning algorithm to train an agent over the process time. Then it coming to the normalized Q matrix after agent is trained, it will print the final updated Q table after the agent is trained. So by seeing these values, we can observe that in the third row and second column, the value is 80, and as also we can see the different values in the process. Uh, After this, we can coming to the challenges that we faced in the Q learning model. So here it is in this process we required like more steps to more steps for the agent to reach from initial state to the goal state in each episode, and it taking like more iterations to for the agent to complete the process to a goal state. Then we need the more computation power in this environment. Buying for the sizes in the bigger environment, it will not work. So for re- so coming to the next updated process, my friend is going to take you forward in the code.
So let's start with the optimized skill learning model implementation to reach the goal state. So usually we do this with a smaller grid. So here we're going to do with a larger grid. The number of iteration an agent makes in single episode is too high when which increases the space and time complexity. Therefore, to have a optimized result, a heuristic function is required which would approximate the Q learning algorithm. So we'll be looking to the heuristic in the following code. Let's start with the function init q. In this function, you can see that there are two arguments n and m. Returns as they return the numpy array of shape in mn filled with zeros, which will be used to initialize q matrix for agent. After defining the function, the code that calls the you can see that there is a initialize to 11 to create a 2D array with zeros with dimension of 11 into 11 and assigns the result array to a variable called Q matrix. And then let's go to the train agent where this is an updated version of the train agent function that we've seen before. In this, you can see there's a gamma value as 0.8, which is a discount factor used for the Q learning to balance immediate and future rewards. And then the timestamp, which is used as a 0, is to encounter the number of steps taken by the agent in each episode. As you can see, there is a current state, which is we just set to call the init state. And then we can look into the visited action is empty listed, which will be used to keep track of the actions that are already been visited. The agent enters a loop where it selects a valid action to take. A valid action is an action that has a non-negative rewards in the current state. So the loop checks if the action has already been visited by the agent. If it has, the action is removed from the list of valid actions. If there are no valid actions left, the agent has reached and dead end and the loop is broken. The agent selects a random action from the remaining list of valid action and it is appends as visited action. The current state of the reward for the chosen action is stored in the current state reward. So as well as for the max where q value of the next state is calculated using q max q matrix action. So as you can see, we have implemented the current state with the gamma next state reward, and the new state is set to the action, and the timestamp is incremented in the function. So let's go with the full training of an agent. As you can see, that the iteration is like a 0 to 500. It is also we have mentioned in the previous state, and from this we can see that the results can be changed from the old state to the new state. Old state is like as far you can consider this if old state is 3 and the new state is 2, which is the updated heuristic output. So this is the whole output that we have got from the total steps for full training process. You can see this here. There's a lot of updated versions. So let's continue with the normalized Q matrix for an agent is trained. So this you can see this a finite updated Q after training. So let's begin with the test matrix for Q learning agent performance when a heuristic is applied. So you can see there's a plot. The plot shows that a comparison of Q learning process between Q learning model with and without heuristics. As we can see, the Q learning model with the heuristic converges faster compared to the Q learning model without the heuristic. So this let's begin with the next visualization to a total rewards for an agent. There is two visualization represented, one with the heuristic and one without the heuristic. The plot shows that the learning process of Q learning of the heuristic and without heuristic.
After deploying the agent and testing the agent, we can see that the total number of steps took to by the agent to reach the goal is 4. So the goal is reached, the start state is 6, and the conclusion is that the Q learning model using heuristic function outperforms the simple Q learning model in terms of performance.